Yes, good morning, good morning, good morning, good morning. All good, all fine. How was your examination? Yes, you have done all the things? Yes, good morning, good morning. All the things done? Okay, good. Yes, okay, very good. Okay, and one more thing I will say. First week, means first day of the week, like it can be Monday or Tuesday, okay, depending on the, like you are having exam on suppose Monday, then first day becomes your Tuesday. You're having exam on Sunday, then first day becomes your Monday. Okay, I'm new to your class, no problem. So basically what I'm saying, that first day of the week, okay, you have to give half time for the revision, because revision is ultimately more important. Multiple times we have to revise, because a lot of time people ask us, sir, when to revise the things. So for the revision, because each week you have to do the revision at the, okay, if you are thinking that I will revise in the Saturday, okay, the previous topics I'm saying, okay, Saturday or Friday there will not be any time, because you will be overloaded with the current week syllabus. So it is better to revise previous week syllabus on the first day of the week. Like you can do on the Monday, Tuesday, okay, Wednesday, depending on the, means whenever your exam is there, exam on the Tuesday, then we can say first day becomes the Wednesday. That day, most of the time we will, okay, go to revision, because on first day you will not be having major things to do. You will not be having more classes, I mean, or you will not be having more homework also on that day. Okay, so this thing you have to keep in the mind, that first day of the week we are going to reserve for majorly for the revision of the previous topics. Current topics you are going to do for full week, but previous topic also must be done. Okay, each week we have to revise the previous, otherwise what will happen, we'll keep on learning new things, and okay, previous things you will keep on okay, it will be, you will keep on deleting from your brain and it will not work. Okay, so today we are having calorimetry. You can write the, okay, KTG was over, now we have to do calorimetry, so you can write, okay, calorimetry. Okay, if I ask here in this one, what are the basically calorie? Calorie, you can say, sir, calorie is the unit of, yes, heat. Okay, now this calorie unit we were using for a long time. Okay, before these standard of units came, before that we were using the basically your calorie. At that time, heat was not considered as form of energy. At that time, from there this calorie word is coming. They were not considering heat as the form of energy. Right now everyone knows heat is a form of energy. They were considering heat just like the fluid, like it can be transferred from one container to other container. So they were taking something like the fluid heat. That theory is basically known as your caloric, or we can say calorific theory, but now we are not going there. Okay, from there only this name came. Okay, that is the, okay, your means unit they were saying calorie. So we can say heat is nothing but the form of energy. Okay, form of energy here. Now if I say for the energy, what are the SI unit? For the energy, what are the SI unit? Because a lot of people do mistakes here. So for the energy, we can say SI unit is, yes, this is your joule. Okay, SI unit is joule. And if I say CGS for the energy, we can say for the energy, CGS is, joule is the SI, and I can write, okay, CGS I'm asking, that is the basically your UX, and this is the CGS. Okay, you know 1 joule equal to 10 power, 1 joule equal to 10 power 7, 10 power 7 argon. We know this thing. Just now unit dimension is going on, so probably, okay, you have seen there 1 joule is equal to 10 power 7 arg. Yes. So CGS we know, and we know the your SI system also. Okay, keep this thing in the mind. So what about the calorie? Calorie is the CGS or calorie is your SI unit? Calorie, I have to consider the CGS or as the SI unit. What you will take? What I should consider this calorie? CGS or SI? There are the Listen, calorie is neither CGS and nor your SI. Calorie is one practical unit. Like one time in the last examination question was asked, we have some are the your SI unit, some are the CGS unit, some are your practical unit. Some of the units are practical units. Practically we use, like if I say for the meter, we can say your meter is the SI, centimeter is the CGS, okay. But we use a lot of time in physics, okay, for the astronomical calculations. We use the angstrom, so the angstrom becomes your practical unit, we can say. So calorie is which unit? Calorie is which one? Practical unit, you have to remember, okay. Think all the time, okay, don't do this mistake. A lot of people are doing this mistake because we know that this is written here for the energy. SI unit is joule and CGS is basically your erg, and 1 joule equal to, we know here 1 joule equal to, that is the 10 power 7 erg. This is the relation, okay. So calorie is the practical unit, and what are the what are the relation between joule and calorie? If I say, then you can say, sir, 1 calorie equal to 4.2 joule. This is the thing, okay. 1 calorie is your actually 4.2 joule, and this is the one practical thing because we are using before these standard of units came into existence. Calorie was used, so still we are using that word calorie here, okay. So 1 calorie is actually equal to 4.2 joule. So if they are saying 2 calorie, we can write 2 into 4.2. They are saying 5 calorie, we can write 5 into 4.2. It's 20 calorie, we can write 20 into 4.2. Means just we need to multiply with 4.2 to get your joule here. Now we can write in the form of energy, okay. Now there are the 2 form of energy. Like if I say this is the one container here, and this container, okay, these are the molecules and temperature is 80 degrees Celsius, and here I can say in this one temperature is 20 degrees Celsius, okay. And can I say this thing that number 1 okay statement, this is the suppose A container and B, this is the heat of A is more than heat of B, or I can say this thing as thermal energy, okay, or internal energy, okay. Thermal energy of A is more than, here we can write thermal energy of B, okay. Which one is more proper, okay? Which statement more proper? Which is more proper? More proper. I'm not asking which is correct or incorrect. I'm asking which one is more proper. Actually, there are the 2 types of energy. One is the energy that molecules have the energy because of their translation, rotation, or vibration, okay. That energy is known as your internal energy. That is the contained energy contained by the molecules, okay. Like I have some energy, that energy I can say the contained energy or internal energy, okay. Contained energy or internal energy, okay. Other energy is basically I will transfer some energy from here to there. So whatever energy I am getting transferred, that I can say is the heat. Means heat is basically content form of energy or transit form of energy. Heat is the which form of energy? Content form is whatever the energy molecules are having, means energy associated with the molecules, or it is your energy in transfer. So answer is heat is basically form of energy, but which form actually it is? It is energy, okay. Energy, which energy? Transit or content form. Transit or content form. It is energy in transfer or energy in transit. It is energy in transfer, okay. Energy in transfer, or we can say it is energy in transit. I can use any word, either energy in transit or I can say energy in transfer, okay. Clear? This word is clear. And then this statement becomes more proper because if temperature is more, it does not mean, okay, it is transferring the energy. We can say its internal energy is more and its thermal energy is more. So which one is proper to say thermal energy of A is more than thermal energy of B? What you are saying, the daily to daily life we use, if temperature more, we say heat is more. Temperature more, we say heat is more. So daily to daily life we are using, there is no problem at all. So we can also use, but as a science student you should know what are the difference between, okay, what are the means actually heat. What is the form of okay? Which form of energy, either content or transient? We should know this thing. Now, for me also, after this class, I am going to take all the time. Okay, all the time. Okay, I can use heat. Okay, because in this chapter, I'm going to consider only transfer of energy. So I will say just heat. Okay. Now, so I hope this one is clear. This page. Just basic things, okay, very basic, the things where we have done here. Now I can see this is the block here, any of the substance is there, and if I am going to supply some energy to this one, then what will happen? Basically, two phenomena can happen. One is the temperature change may happen here, so this is the known as temperature change. Other thing is, its state can change, it can change from the solid to liquid, liquid to gas, like this. This change of state is basically, we can write state change, or we can say this is known as your phase change. So two things happen, so either temperature change, either your state change. Okay, temperature change or phase change. Which will happen first? For the temperature change, we have the formula Q equal to ms delta theta that we are going to use today, and for this one we have Q equal to ml. These are the only two formula because you are very familiar with these formula. So Q equal to ms delta theta and Q equal to ml here. Yes. So which will happen first? Temperature change or phase change? This answer I need. Temperature change or phase change? Because here, suppose they ask, okay, that heat is supplied to an object, which will happen first? Your temperature change or phase change? Okay, so most of the people are saying here that is the temperature change. Okay, mostly people are saying temperature change. Okay, then let me ask one question. Okay, then you will tell. After this question, you have to tell the answer for. Listen, if I say ice, then ice can be from negative temperature to the 0 degrees Celsius. Water zone starts from 0 to 100. Means water is saying, I am the king here from 0 to 100. No one will enter into my territory. 0 to 100, no one will come. Okay, I am there only. Okay, 0 to 100 is for water. And after this water, there is the steam. Under normal condition. Again, I am saying under normal condition because some of you might be thinking, sir, if I change the pressure, then I can change melting point and boiling point. Yes, if we change the pressure, if we change the conditions, then we can change the things by adding impurities, by doing the pressure. So if I do something, then of course I can shift these points, but normal conditions, melting point and boiling point is not going to change. So I can say water is going to be from 0 to 100. More than 100, there will be the steam. Lesser than 0, there is going to be ice. Okay, I hope this everyone is clear here. Yes, so we can say that if ice is basically at lesser than, then it will be max. What can be the maximum temperature of ice? If they're asking what is the maximum temperature of ice under normal condition, answer is maximum temperature of water under maximum temperature of ice under normal condition. Zero. Okay, maximum temperature of water under normal condition. Maximum temperature of water under normal condition. This is going to be 100. Okay, this is going to be 100. Yes. Now, if I ask this question to you, suppose I have ice at 0 degrees Celsius. 0 degrees Celsius ice, if I heat, what will happen? If I heat 0 degrees Celsius ice, then what will happen? Its temperature can increase. 0 degrees Celsius ice you have, its temperature can increase. Temperature will increase here. Temperature change will take place in this case, or phase change will take place. You will say, sir, it will melt, because you cannot increase temperature of ice more than 0. Maximum temperature of ice is 0 degrees Celsius. More than 0, not possible. So first of all, what will happen? First of all, what will happen? Here is a first of all, in this case, it will be converted to water at 0 degree Celsius. After that, you can increase the temperature. Okay. Means in this one, I am saying that when temperature is changing, at that time phase is changing. When temperature is changing, okay, at that time phase is changing. When temperature is changing, phase will change. Phase will not change. When temperature will change, phase will not change. Means only temperature change process will happen. And when phase is changing, during phase change, okay, during phase change, temperature will change. During phase change, temperature will change. Means if I say during phase change, okay, temperature will change or will not change. During phase change, temperature will change. Temperature will not change. Temperature will not change. Can I say this thing? During phase change, temperature remains same, because at a time one process will happen. Okay, either temperature change, either pressure change. So during phase change, temperature remain constant. Okay, during phase change, temperature remain constant. Any problem here? During phase change, temperature remain constant. Okay. Now, so we know that at a time one will happen, either this one, either this one. Okay, when this is happening, this will not happen. When this is happening, this will not happen. Okay, so which is going to happen first? Again, I'm repeating the question now. Which will happen first, temperature change or phase change? Because we have seen in the previous example here, ice to, when ice is there, you have 0 degrees Celsius, then what is happening first? Here first phase change is happening. Okay, it actually depends. Now you got the correct answer, sir. Actually depends what you have. If I have here, then we can say this is the your phase change. But if I say suppose you got minus 20 degrees Celsius ice, so yes, sir, minus 20 ice will increase the temperature up to 0 degree Celsius. Minus 20 ice will increase its temperature to 0 degrees Celsius. And here what is happening? Basically your temperature change. Here your ms delta theta I am bringing temperature change. So it will depend, okay, what you have the initial condition. It depends on the initial condition. Anything can happen first, either temperature change or the phase change. But only two things are possible, either this or this. If this is happening, this is not happening, and when this is happening, this is not happening, means they will come always alternate. Okay, alternate they will come. Okay, like if I say I'm continuously supplying the heat, so let's say these are the two examples. These examples, okay, we'll write later on also. So like ice and water. Okay, ice you are heating. So if you are heating ice, then what will happen? You can say ice 0 degrees Celsius will be converted to water 0 degrees Celsius. And what is happening here, first of all, basically, because maximum temperature of ice is 0, it cannot be increased. You cannot increase more than this. So here, this is the phase change, that is the ml. Okay. And then we can write here water 0 degrees Celsius. Water 0 degrees Celsius will be converted to. Now you can increase the temperature of water. And what can be the maximum temperature of water? Maximum temperature of water can be here in this case 100 degrees Celsius. Maximum temperature of water can be 100 degrees Celsius. So now we can see here again your temperature change. Once water reaches 200, you cannot go beyond this one. And when you cannot go beyond this, then water will be converted to your steam, means, okay, this is converting to steam. So again, phase change. You can see here 100, during phase change, temperature will not change. 100 water to you will get 100 steam. Okay. If they say I need 200 steam, then you can say again I can increase the temperature to 200 degrees Celsius steam, and again here ms delta theta. This ms delta theta and ml will be coming alternate. They will not come together. 2 ms delta theta coming anywhere in your question, it means question is wrong. 2 ml coming together means question is somewhere you have done the wrong calculations. They will come always alternate. Temperature change, phase change. Temperature change, phase change. Like this will keep on happening. Okay. I hope this flow is clear. Ice 0 degrees Celsius. So 0 ice to 0 water, 0 water to 100 water, 100 water to your 100 steam, and 100 steam to 200 steam, 300 steam, any steam we can form. Okay. Here we can write in this one. Suppose, sir, because maximum condition, if I say maximum condition, then ice can be at some negative temperature. Max to max, if I take ice can be somewhere at the negative temperature. Okay. And steam can be somewhere at the extreme temperature, like 200, 300, 500, 8,000, like this, okay? Some extreme temperature. This is the maximum question anyone can ask here. Max to max, anyone can ask like this. So I can write now in this one, ice minus 20 degrees Celsius to 0 degrees Celsius. 0 degrees Celsius ice will go to your water at 0 degrees Celsius. Okay. Then 0 water will go to water at 100. Water 100 will go to your steam 100. Steam 100 can go to steam 200, steam 300 degrees Celsius. You can write here. So again here what is happening? Your ml. Here again ms delta theta. Again here your ml. Again ms delta theta. I hope this temperature change, phase change examples are clear. How we have to move forward. Ice. Maximum temperature of ice is 0 degrees Celsius. More than 0, ice cannot exist. Okay. Yes. And maximum temperature of water can be also 100 degrees Celsius. More than that, water cannot exist. It will be having your, okay, it will be converted to your steam. Crystal clear. Very good. Okay, crystal clear. I hope this is crystal clear because we are going to use these things in our numericals. Okay. So I will go. Okay, going back here again. So we can say anything can happen, temperature change or phase change, and during phase change temperature remain constant. If I say energy is supplied to an object, then temperature must change. Like if I ask one question based on this thing, okay, if energy is supplied, I will write here, if energy is supplied, energy is supplied to an object, okay, you have to select correct option. Temperature must change. Phase must change. C option here. Temperature may change. D option. Phase may change. Yes. What will be the possible answer in this one? Means in this 4 options are given here. Out of this, what you can say? You can say sir, temperature may change, either phase may change. Must we cannot take, because must means only I am confirming that only this thing will happen, which is not okay. Anything is possible, either this or this. So temperature may change or phase may change. Okay. Yes, so answer becomes 3 and 4 here. Okay. Now we'll write the heading here, temperature change, and then we'll do some questions on this one. Temperature change, then we'll do the phase change, and then we'll do the combined questions. So next heading is temperature change. Okay. Now for the temperature change, we know that this is the Q equal to here ms delta theta. This is the simple formula. Q equal to how much your ms delta theta. Okay. Q equal to how much your ms delta theta. Okay. Now we can write here in this one that Q, everyone knows that is the energy. Okay. This one, if you don't know, I am writing here, but hopefully you know. M is the mass. Okay. Delta theta is the temperature change. And listen, temperature change in the Kelvin and degree Celsius is same. Okay. And if temperature change in the Kelvin and degree Celsius is same, then there is no difference. Okay. We can take, okay, in the delta theta, we can take in the your degree Celsius or Kelvin, both are same. In this chapter, there is no problem that you have to convert directly. You can find the temperature change in the Celsius, which is equal to the Kelvin change. S is known as basically your specific, okay, specific heat capacity. Specific indicate, okay, here specific indicates that it is going to be specific for a material. Means this depends on nature of material. It depends on material. It will be different for different material. Means depends on nature of material. Okay. Depends on nature of material. Okay, depends on nature of material. And you know, whatever things depends on nature of material will depend on temperature also. Whatever things depends on the nature of material will depend on temperature, but we are going to take constant here. Okay, we are going to take constant. Means if I say some of the specific heat, you need to remember specific heat of water. We cannot remember for all the material available in this okay, universe. We cannot do so, but water we need to remember. For water, value is 1, but 1 will not work. You need to remember with the unit 1 calorie per gram degree Celsius. Okay, 1 calorie per gram degree Celsius. If I say it's units, we can say sir Q by M delta theta. Okay, if I say SI unit, then you can say SI Q will be the joule per mass will be the kg, and delta theta will be Kelvin. This is the SI unit. Other than SI, I can write so many units. Okay, joule per kg, Kelvin, arg per gram. Okay, like this I can make practical unit. I can take 1 calorie per gram, and if I convert, then it becomes 4200 joule per kg degree Celsius. Okay, this one is basically SI unit. Okay, you can say sir SI you told Kelvin. Kelvin degree Celsius is same here, so I have written this way. Okay, now so one is the CGS, one is the CGS, one is the CGS. Muhammad Safruddin Khan, what will be the cutoff for OC Telangana local? You are asking wrong question in the wrong at the wrong place. This question you need to ask in the meeting time, okay? Not now. It is the practical unit. One is the practical unit, okay? One is the practical unit, okay? So, which will be easy for us to use? Which will be easier for us to use? 1 or 4200? 1 or 4200, which will be easier for us? Of course, you know that 1 will be easier for us because if multiplied, 1 multiplied anything will remain same. There will not be any change. So most of the time I will use 1. But you have to be careful when you are using this 1 value. Then mass you have to take in the gram and energy you have to take in the calorie. Okay, energy will be coming in the calorie. If you are using this one, then mass will take in the kg and then energy will be coming in joule. Specific heat unit will tell what will be the answer, what you need to consider. Like if I say example, suppose anywhere a specific heat they have given that 5 calorie per kg degree Celsius. It means I am going to take mass in the kg and energy will be in the calorie. Somewhere they have given 2 joule per gram. It means mass I will take in the gram and energy will be in the joule. Energy will be in the joule. Yes, clear? I hope this point is clear now. Means specific heat unit will tell what to consider. You will not ask me or you will not ask anyone. You will ask specific heat, what how to take mass. Specific heat will tell, just take this thing in, okay, take mass in kg or gram, and okay, I will get energy, I will get answer of energy in the calorie or joule or arg. Specific heat will always give you answer. Okay, so just check the units of specific heats are quite crucial for us. That will give you full information here. Now we can say specific heat for ice is going to be, that is your half calorie per gram degree Celsius, or I can say it becomes 2100 joule per kg degree Celsius. This is your SI unit here. Okay. Now, again, here half is much better to use. Okay. So I will use most of the time half, and then we can say then comes your S vapor, and vapor or steam I can say this is basically 0.47 calorie per gram degree Celsius. I am not converting this one because if required I will use 0.47. This most of the time I will prefer 1 half and 0.47. Later on I can convert if required, because everyone knows, okay, 1 calorie is nothing but the 4.2 joules. So later on I can convert, because this conversion will be much easier rather than taking the 4200 and 2100. Calculation will be taking lot of time. So later on we can convert if asked. Yes. Can we write the next thing? So these are the 3 values that you need to remember. Specific heat for water, ice and vapor. For any other material, specific heat will be always given to you. Okay, specific heat will be given to you. Okay. Next thing we have is water is used as coolant. Why water is used as coolant? Can you tell me the things? Are in the engine, car, so much energy generated, na? Then we have to cool this engine. Now advanced coolant are there in the market, okay, but earlier time if I say now also that whatever the coolant we having, these are the water based only, okay, they are the water based, but okay, previously we were using only water, simple water. Okay, why water is used as coolant? Because of high specific heat. You can write water used as coolant because of high specific heat. Water used as coolant because of high specific heat. Okay, now because of high specific heat. Okay, if specific heat is more, like this S is large, then Q required is also large. Okay, so for some change of temperature, if S is large, Q is going to be large. Which water, okay, needs huge amount of energy to heat or to cool. We need to remove huge amount of energy. Mr. Water will be heated. Water will be heated quickly or slowly? Water heated quickly or slowly? What do you say? Water heated? Yes. Slowly heated, slowly cooled. Okay, so in the bracket you write, okay, heated slowly, cooled slowly. Okay, heated slowly, cooled slowly. Okay, water heated slowly and cooled slowly. Okay, this is the one property that we need to to remember. Okay, let me give you example for this one. Okay, suppose we got one engine. In that engine we got huge energy generated, because major in okay, engine will be one topic in which I will tell that major part of the engine is converted to heat. Very less part we are going to convert into your work. Means efficiency is not very huge. Efficiency is okay, quite less. It can be your okay 8%, 10%, 20%, like this. Means most part of the energy is going to be in heat form. So now we can say, suppose in engine we got 84,000 joule. Okay, 84,000 joule energy is okay generated in the engine. Okay, then we can say this energy should be absorbed. If you don't absorb this one, then what will happen? Energy will be heated and your engine is going to be damaged. So to absorb this, what we need basically in this one, to absorb this, what we need? We need to absorb. So I can take one bucket, okay, a small bucket actually. That a small bucket is your 10 kg water. Okay, I will just use, you know, Q equal to mh delta theta here. So now we can say m becomes here in this one 10. Now this is joule, this is the kg. So better to use here 1 or 4200. In this one I can use 1 or 4200. I can use 4200 into delta theta. Now you can say, sir, 30, 1, 2, 3 and 1, 2, 3 cancelled. So delta theta actually becomes 2 degrees Celsius. Change of 2 degrees Celsius even may not be noticed also. This is a very small change, may not be noticed. Means water can absorb huge amount of energy, and its temperature will just increase by 2, and that 2 is not the major change. Means even though more than this energy is also generated. Okay, if I say this is 84,000 hot again, even though here we are getting 8 lakh 40,000 also, 8 lakh 40,000, then what will happen? 8 lakh 40,000 means 20 degrees Celsius change will be there. Means water can actually absorb huge amount of energy. Okay, this example tells. Now this example we can write as the numerical. Okay, so I'm writing the question. They can ask the numerical also. Find this is the one example also to explain how water is used as coolant, and then we got find rise in okay temperature of 10 kg water if 84,000 joule energy supplied. Okay, like this they can ask the numerical also. So we have written the numerical, as well as we got this okay feeling also how water is used as coolant. I hope you got the feeling, because feeling is more important. You need to feel when you are writing something. Yes, water is used as the coolant. Clear? Okay, can we write the next question now? Next one. Okay, so I will be writing one next question. This one is you have to solve. Okay, they are saying find find heat required to change temperature of 2 kg water from 27 degrees Celsius to 77 degrees Celsius. Okay, so this is the question. Find the heat required to change okay temperature of 2 kg water. So now we can say we have to find the Q equal to, we can use ms delta theta here. Now I can say mass is given in the kg. Okay, so I am now free to use any unit. I can take 1 also as well as 4200 also. Which one should use? 140. Now you will see the options. If option is in the calorie, we can take 1, and option is in the joule, then you can take 42. Then we can take 4200. If option in the joule, we can take 4200. Option in the calorie, we can take 1. Depending on the options, we can take the things. Okay, so suppose if I take here in this one calorie, because I will solve in the both way. Okay, calorie as well as joule. So for the calorie, I know I cannot write 2. I need to write 2 into 10 power 3. If I am solving this question in the calorie, this mass must be taken in the gram. So 2 into 10 power 3 specific heat I will take 1. If I am taking 1, then mass only 10 power 3. Delta theta 27 to 77. That is nothing but the 50. 50 into 2 is 100, and this becomes 10 power 5 calorie. Okay, this is the calorie. If you want in the joule, then you can just multiply with the 4.2. So we are multiplying here with the 4.2, and this becomes finally here 4.2 into 10 power 5 joule. Okay, I hope this one is clear. So we can calculate in the calorie as well as joule. Only thing, okay, if you want in the joule directly, you can use 4200 also, or we can calculate in the calorie and then later on we can just use 4.2. Okay, I hope this one is clear. Very small. Okay, nothing is there in this question. So now we are going to write next thing here. Yes, ready? Huh. Completed? Listen. I have told you Q equal to, there was the ms delta theta. If I say there is a very small change in the temperature, means whenever specific heat is variable, I said specific heat is constant. When specific heat is constant, then there is no problem. We can freely use ms delta theta. I mean, if specific heat is variable with temperature, and if specific heat is variable with temperature, then you know that different temperature, specific heat value will be different. And a specific heat value is different at different temperature, then I cannot use ms delta theta formula. Then we need to do the integration, because you know wherever variable things are there, then integration is preferred all the time. So what we can do, Q equal to, we can write, then we'll write for small energy if temperature changes small, but we are writing this thing only whenever your specific heat is variable. Okay, so now I can say dq equal to ms dt. If I do the integration both sides, then you can say dq will be the q equal to, I can write integration of ms dt, but this one we are going to use this differential form. This is known as your differential form. If as as variable, okay, if s is varying with the temperature, then we can use integration form. Most of the time integration form is not going to be used for us. Okay, but we should know how to do the thing. Suppose anywhere comes, we can do. Okay, so can we use this one, integration of ms dt? And integration, you are perfect in the integration of t, integration of x, x square by 2, x square, x cube by 3, like this we know, no? Okay, so write one question here. Question: a specific heat of a material at low temperature varies as s equal to 80 cube, s equal to 80 cube, a constant. Okay, some a is some constant. Find energy required to raise temperature of unit mass from 1 Kelvin to 2 Kelvin. Okay, this is the question. Please try this one. Okay, a specific heat of a material at low temperature is varying according to this one, and then they are asking here from 1 Kelvin to 2 Kelvin. This is just okay, very simple integration here. Yes, what will be the answer? Yes. Okay, so most of the people got the answer here. Listen. So I can say in this one, okay, I have to use the same formula. Q equal to, you can say integration of unit mass, means mass is 1, okay, unit mass 1 into s is 80 cube into dt, and this is from 1 to 2. We can say, sir, a will be outside, okay, a is outside, and then we can it integration of t cube. Integration of t cube will be t power 4 by 4, okay, t power 4 by 4 from 1 to 2. Okay, this one we can say integration of t cube. Integration of t cube is equals to t power 4 divided by 4 x power n plus 1 by n plus 1. So now right here this thing is there, and then we can write a by 4. One time we have to put upper limit and one time we have to put lower limit. Okay, so we can say this becomes 2 power 4. So here we got finally in this one a4. This is the 16 minus 1, and then we can say it becomes 15a by 4 is the answer here in this one. Okay, now actually if we say a specific heat we take as the constant, but already I said a specific heat is not strictly constant. It will depend on temperature slightly, like this we have done one numerical. Okay, if I say a specific heat for the copper or for the metal, actually it is changing like this. Okay, this is the specific heat. Okay, a specific heat, and this is given with the temperature, and this is actually for the copper. Okay, this graph is for copper. We can say for the material this type of graph means at the high temperature this becomes almost constant, but the low temperature some variations are there. Okay, at low temperature some variations are there. Can you keep this graph in the mind? Some variations are there, like this is the graph for copper. Okay, at low temperature some variation means specific heat is not exactly constant, some changes are there. However, these changes are very less. However, these changes are very less. Okay, I hope we got this one. Yes, we got this thing. Okay, so remember this graph you have to keep in the mind. Okay, keep in the mind that graph is like this. It is the graph of actually your t cube graph. We can say this way graph is there. Okay, this is for the copper, or we can say most of the metals follow this thing. Okay, if they're asking for any other metal also we can say same way. For water graph is different. Okay, this is for water. Okay, if I say this was for the copper and this is for water we have graph like this. This is the graph for water. Okay, like this will be the graph for water. Okay, this is the graph for water. Okay, specific heat for the water is changing like this because specific heat for water is also changing, but variation is very less. Now you can say, sir, you are saying it is changing with the temperature for all. Okay, and can we remember all the graphs? No, you don't have to remember all the graphs. For the copper and water, that is more than enough. Okay, some variations are there. Okay, for the water graph like this, and for the specific heat this way for the copper. That's it. Okay, we don't have to go for all the materials here. Right, the next one now in this one, there's a phase change. Okay, so now we'll be writing here phase change. So phase change means basically we can say here we have one formula that the Q equal to ML. If I say what the L here, Q because you know, M you know, what the L here? L is known as, L is basically your latent heat. Latent means hidden. Okay, and this phase change means ultimately will be going from solid to liquid. Some of the bonds are broken, new bonds are formed. So there are some changes in the structural changes are there. Okay, and that actually we are not able to notice. So we can say this one, this heat is used for the hidden process, or we can say this one hidden heat. Okay, now we can say two phase changes are there that we need to do. Number one is basically ice to water. Ice to water, this process is known as fusion. So we can write this is, here we can write this Q will be equal to in this one MLF. Means here in this one process energy is equal to MLF. LF is known as your latent heat of fusion. Latent heat of fusion. Okay, LF. And then we can say LF is, value of LF is 80 calorie per gram. Okay, LF is 80 calorie per gram. I am not converting this one into your SI. If you want, you can convert. Calorie you can convert, already told you. Gram also you can convert if required, but we are going to use only 80 calorie per gram. Okay, next one is here, second one that we are having in this one, that is the water to, okay, we are having water to steam. This process is known as vaporization. So this LV is actually known as your latent heat of vaporization. Latent heat of vaporization, and this value is actually here we know 540 calorie per gram. Actually its correct value, exact value is 536 calorie per gram, but you know which was which will be easier for us to do calculation, 540. So mostly we are going to use 540 here, okay? And if options are very close, like one option is one option you got suppose 700, next option 701, 702, 699, then we are going to use exact value 536. Otherwise we have to take only 540 everywhere, okay? We are going to take everywhere 540 in this one. I hope we are ready for the questions. Yes, right. Find energy required to convert 1 gram ice at minus 20 degrees Celsius to steam at 200 degrees Celsius. 1 gram ice at minus 20 to steam at steam at 200 degrees Celsius. First of all, you need to get the question, because this question I will tell, okay? This question, if you get any other question, you can get easily, okay? So listen this question carefully here, okay? So we can say, sir, you have ice. How much is there at 1 gram actually? At temperature of minus 20 degrees Celsius, okay? Now I can say if I heat this one, final destination is here actually your steam. I need the steam at 200 degrees Celsius. So it's the same as usual that you have told us earlier. Ice, if you heat, then first of all, what will happen? Ice will be converted to zero ice. Directly you cannot go. You have to write each step. If you are missing one step, question will be wrong, okay? 0 degrees Celsius. Then 0 ice to, I will go to your 0 water, okay? Then 0 water, I will go to. From 0 water, I will go to. You can say, sir, you can go from 0 water to 100 water. 100 water to your, we can say, we can go to 100 steam. 100 steam to, I will come to your 200 steam. Now I can say here in this one, ice to ice, of course, phase not changing. What is changing here? Temperature, so we can write ms delta theta. Ice to water means phase changing, so we can write mlf. Okay. Here again, water means temperature changing, ms delta theta. Here water to steam is phase changing, so mlv. And again, we can write here ms delta theta. Whenever you have doubt, you can always cross check that ms delta theta will not come together. 2 ms delta theta will not see, and you will never have your ml also together. So now we can write in this one. Okay. Now we have to do the calculation. So this is the one, that is the mass, a specific heat. Okay, that way. Okay, what is the specific heat for the ice? Half. Okay, 1 into half. Specific heat is half. Temperature change 20 to 0. So 20 to 0 means that is the 20. So this actually becomes here 10. Okay, that is the 10. Here I can write in this one 1 into 80. That becomes your 80. Okay, 1 into LF is 80. So that becomes 80. Here I can write in this one 1 into specific heat is 1 into 100. That becomes in this case 100. Okay, so this way we have to calculate. First we can write the formula and then we can do the calculation here. Then I can write in this one 1 into LV, that is the 540. So this becomes 540 here. And here I can write it becomes into, and 47. This plus this is the total requirement, and if you add, then finally answer becomes here 777 calorie. Okay, so see this one. If this question is clear, the remaining question becomes very easy for us. If this is clear, then remaining questions are nothing for us. We can easily do. Okay, yes. So now online, how? Okay, what are the maximum marks in online? Maximum marks, because in offline 700 is the maximum. What about online? They released the marks list. It's already you got not posted yet. Arey, you got miss, just after the exam you are getting your marks. Huh? Okay. Now can we do one more question? Okay, good. You can convert into joule also, okay? If you require, then you can answer 777 into 4.2 joule, because they can ask answer in the joule or calorie, any, okay? In any unit they can ask. So are we ready for next question? Right. Convert 20 gram ice, 20 gram ice at 20 gram ice at 0 degrees Celsius to water at 80 degrees Celsius. 20 gram ice at 0 degrees Celsius to water at 80 degrees Celsius. Water at 80 degrees Celsius. So now we can say 0 ice to, first of all, you will get the, okay, here, you will get the 0 water, and 0 water to, you will get to your 80 water. This is the question here. So I can write here in this pen, this will be the MLF, and this will be the your MS delta theta, okay? After some time, will not write these steps, only here, only directly I can write, okay? So yes, sir, MLF, M is 20, LF is 80. So this is the 1600, and here we can write your M is 20, S is 1, delta theta is 80. This is also 1600. So total energy actually becomes here 30. 200 calorie, if you need in the joule, you can multiply with 4.2. Yes? And we got this answer? Huh? Later on, we'll write directly. We'll write directly here in this pen. What we'll do here, we can directly write your first MLF, then MS delta theta. Okay. This way we can reduce the calculations. Sometime we can reduce all the, okay. Next question. Find heat required to vaporize 5 gram ice. Heat required to vaporize 5 gram ice. Ice temperature not given. If ice temperature is not given, then which temperature you will take? If ice temperature is not given, then which temperature I will take? What temperature I have to take for the ice if not given? If ice temperature is not given, then I have to consider 0 degrees Celsius. Steam temperature not given, I have to take 100 degrees Celsius. Okay. So now we can say, as per this question is saying, ice 0 degrees Celsius, I will go to your water 0, and from water 0, I will go to water 100. Okay. And then I will just, okay, vaporize means I will convert this one into vapor. This water 100 will go into your steam 100. Steam 100, that's it, and you will stop there. So now we can say this one is the ice 2. This is first of all what? MLF, MS delta theta. Again we can say MLV. Let's calculate the things here. So we can say, sir, in this one, M is 5, LF is 80. It is the 400 here. Next one we can write 5 into 1 into 100. There is the 500, and here I can write, okay, 5 into 540, there is the 2700. So this plus this, if you say, then total becomes 3600. Okay. Done? Yes. Over this question. Can we do next one? And the next question. If you are moving forward, like, okay, you are going from solid to liquid, liquid to gas, then energy is absorbed. And if I'm coming back, like vapor to liquid and liquid to solid, it means in this process, energy will be released. Because, you know, gases are having more energy. Liquid is having more energy as compared to the solid. So solid means, if I say energy like this, solid, liquid, gas. So if I'm going upside, then energy will be absorbed. Coming back, energy will be released. Okay. So can I ask the reverse question? I will ask, okay, right, find heat released if 5 gram steam condensed to 40 degrees Celsius water. 5 gram steam condensed to 40 degrees Celsius water. Now we can say this is the steam here, okay? Steam temperature not given, we are going to take 100 degrees Celsius, and this one is 5 gram here. Steam 100 degrees Celsius, okay? Now we are writing the same thing in the reverse way, okay? Reverse process. So steam 102, we can say water 100, and then water 102, we have to get water 40 degrees Celsius, okay? First of all, this flow should be very clear, okay? You can write this one. In this case, energy will be released, or how to remove the energy. So you can say, first of all here, MLV, and then here MS delta theta. M is 5, LV is basically in this one, okay, 540. LV is the 540, so we can write 5 into 540 becomes 2700 here, and here I can write in this one 5 into 1 into, okay, 60, that becomes 300. So total energy, if you say, that becomes how much? Your 3000 calorie. Yes, this is clear. So can we solve questions? Reverse question also, means forward as well as both way, okay? Forward means energy absorbed, reverse means energy will be released, okay? So can you do practice for these questions? Because some practice is required. One more question I will give, then I will leave the class, and after that you will do the practice, okay? Because practice ultimately you have to do, okay? So one last question, and okay, then you will do this one, because if you are same process is same, there is no difference at all, okay? No negative sign, no need to take, okay? No need to take positive, negative, okay? Because we know we can write now this much energy released, okay? So because you know positive negative will create confusion, okay? That's why I'm not putting. I know that this side energy absorbed, back side energy released. So they are already asking in the question release, okay? If they're not asking, we can specify this much energy will be released, okay? So we are going to avoid wherever, okay, confusion arises. So because of the positive negative, some confusions, we'll avoid, just we'll take the difference for the calculation. Don't say, sir, 40 minus 100, I have to take minus. No positive, no negative, just difference you have to take, okay? So find, okay, this is the one next question here. Ice minus 20 degrees Celsius, 15 gram, and you have to convert to, okay, water at 0 degrees Celsius, okay? If you have to convert water at 0 degrees Celsius, I can write directly in this one. So ice minus 20 ice to 0 ice. In some questions, they ask to find common temperature. Common temperature will do, don't worry, okay? That is coming in the mixture. Mixture we have not started it. Mixture will do in the next class, okay? Today we are doing the basic question, because if this is clear, then question of mixture will be clear. And if these things are not coming, then mixture becomes very tough for us. So listen, minus 20 ice to 0 ice. In this today class is the just basic class. Very, very basic, fundamental class. If we are okay in this class, then only we can move for the mixture problems. Otherwise, I cannot directly start the mixture problem, okay? So we can say ice minus 20 to ice 0. So first of all, MS delta theta, and then we get ice 0 to water 0. So MLF. Can I write directly like this also? Miss, I will not write the two steps. I can just write in the single step here. Now I can calculate. So you can say, sir, M is 15 into S value will be half, because ice will be heated. Ice will be heated, so it will be your half. So I can write half. Delta theta will be 20 to 0, so that will be the 20. Plus we can write 15 into 80. So this becomes here 150 plus. So final answer becomes here 1350 calorie, okay? I hope this one is clear. Steam to water also MLV, and water to steam also MLV. Yes, okay. Water to, okay, I said in the, if you say here, okay. When I was saying where, this one, okay. Ice to water value is LF, and water to ice is also, okay, LF. Only thing that here energy absorbed and here energy released. Same thing here. Here MLV and here also MLV. Only difference is here energy absorbed and here energy released. Absorbed, released. That is the only difference. Okay. MLV, MLV, MLF, MLF. Energy absorbed, energy released. Okay. And then okay, I hope this question is clear to you. Yes. Okay, so other things we'll write in the next class, okay? And practice these things, then only we can do the questions of mixture, okay? Properly, otherwise it becomes somewhat tough for us to do the questions of mixture. Okay, bye. Bye, bye, bye.